Chapter 4, Section 4 is still about solving inequalities, but this time there's going to be more than one step. So by the end of this lesson, you should be able to solve multi-step inequalities with variables on one side, and then you should be able to solve multi-step inequalities with variables on both sides. So let's start with variables on one side. If I want to get x by itself, remember that our rules for inequality are the same as our rules for equality. So you always have to undo PEMDAS backwards. So remember we had SADMIP. Same thing works for inequalities. Undo your subtraction and addition, and then your division and multiplication. We won't ever have any exponents. And then we're going to do parentheses a little later. So to get x by itself, all you have to do is add 4 to both sides. And then I have negative 3x is less than or equal to 18. And then divide both sides by negative 3. Now the thing you have to remember is that if you divide by a negative number or multiply by a negative number, your sign has to change directions. So instead of munching on the number part, it's going to munch on the variable part. And then an important part of this is check your solution. Make sure it works. So this solution says that I want all the numbers that are greater than or equal to negative 6. So pick any number you want that's greater than negative 6. How about 0? So if we plug that in, we get negative 3 times 0 minus 4, and I want to know if that's less than 14. Negative 3 times 0 just gives me 0, and negative 4 is definitely less than 14. So this next one, same situation, we want to get the t by itself. So I have to undo this 7 here. And I know there's a minus here, but that's minus the 2t. So this 7's positive. So to undo it, I'm going to subtract 7 from both sides. So I get negative 2 is less than negative 2t. And then divide both sides by negative 2. So again, I divided by a negative number. I'm going to have to change the direction of the inequality. This will give me positive 1 is greater than t. Now you can leave it like this, or you can write the mirror image, which would say t is less than 1, but these are the exact same thing because the alligator is munching on the 1 in both directions. They're just mirror images of each other. So let's try a little bit harder one. The school band needs a banner to carry in a parade. The banner committee decides that the length of the banner should be 18 feet, and a committee member drew this diagram over here to help us understand the problem. What are the possible widths of the banner if they can use no more than 48 feet of trim? So the trim has to go all the way around this banner. It has to be like the perimeter. So think about what we know. Perimeter is 2 times the width plus 2 times the length. We know that they have 48 feet of trim, and we know that it has to be no more than 48 feet. So that's the most we can work with. So when we put our little inequality in here, we want all of this stuff, whatever is right here, 2 plus the length, plus 2 times the width, that needs to be less than or exactly equal to 48, because we can't use any more than that. So then plug in what we know. We don't know what W is. They gave us just a W there. But we know the length is going to be 18. So if we simplify this, 2 times W, 2 times 18 is going to end up giving us 36. And then we got to get W by itself. So we got to subtract 36 from both sides. So leave me with 12 is greater than or equal to 2W. And if you divide both sides by 2, you get that 6 is greater than or equal to W, which I would rewrite this way, that you need your width to be less than or equal to 6. If you use exactly 6, you'll use up all 48 feet of trim, and if you use something less, you'll have a little bit of trim left over. So now let's do stuff with parentheses. Now, even though we're solving, you still have to simplify before you can get x or p or m or w, whatever, by itself. So in this problem here, we need to get rid of this parenthesis before we can get p alone. So we're going to have to distribute. So 2 times p gives me 2p. 2 times 7 gives me 14. And then it's less than 8. And then we're still simplifying. So we got to combine our like terms. And now that it's as simple as we can make it, we can start to solve. So let's undo this plus 14 on both sides. We get 6p is less than negative 6. And then undo multiplying by 6. Now be really careful here. We divided by a positive 6. So even though our answer is going to be negative 1, our sign is going to stay in the same direction. Remember, that only happens when you multiply or divide by a negative number. And you can still check this. We want all the numbers that are less than negative 1. So a number that would fit that would be like negative 2. That's less than negative 1. And go back and plug that back in. 4 times negative 2 plus 2 times negative 2 plus 7. We want to know if that's less than 8. So 4 times negative 2 gives me negative 8. Inside of here, this gives me 5. And if I do 2 times 5, I get 10. And if you add those up, you end up with 2, which is definitely less than 8. So now same thing for part B. We want to get m alone. So before we can do that, we have to distribute over here. So this part's going to stay the same. And then I'm going to have to distribute this negative 2. So negative 2 times 4m will give me negative 8m. Negative 2 times 7 will give me a negative 14. So still simplifying before we can start solving. With like terms here that we can combine. So I have negative 8m minus 9. And now that it's as simple as can be, we can get m alone. So I'm going to add 9 to both sides. This gives me 24 is less than or equal to negative 8m's. And then divide everything by negative 8. So my answer becomes negative 3. Because I divided by a negative, I got to change the way my sign faces. And then we just have m left over. And remember, you can write the mirror image of this, but make sure the alligator is still munching on the negative 3. So now that we've done enough of variables on one side, let's do some with variables on both sides. It's exactly the same as when we solve equations with variables on both sides. So for this first one, we have b's on both the left and the right, and numbers on the left and the right. So we got to choose a side. I'm going to move all my b's over to the left. And the reason I decided to do this is because I will end up with positive amounts of b's if I do this. Where if I subtracted 3b, I would have ended up with negative 5b on this side. And then I would eventually have to divide by a negative number. So less work to add the 2b over here. And now this looks like all the other problems that we just got done doing. So I'm going to subtract 12 from both sides. Okay, the 5b is greater than 15. And then divide both sides by 5. So we get that the solutions are any number greater than 3. Now, final problem. This one looks a little complicated because it has those two sets of parentheses there. But all we got to do is simplify both sides. So I got to distribute this negative 6 here. And then be careful when you multiply negative 6 times negative 4, it should give you positive 24. It's greater than or equal to some more distribution over here. So I have 7 times 2x, and then 7 times negative 3. And now this looks just like this problem up here. Get x by itself. So when I go to combine these, again, I notice that if I subtract 14 from both sides here, I'll end up with a negative. Not the end of the world, but I'm going to avoid that and add 6x to both sides over here. So this crosses off. I get that 24 is greater than or equal to 20x minus 21. Now if I add 21 to both sides, I end up with 45 is greater than or equal to 20x. And to get x by itself, I'm going to divide both sides by 20. So over here, it goes in twice with a quarter left over. 2.25 is greater than or equal to x. And remember, you can write its mirror image. X is less than or equal to 2.25. So you should be able to solve multi-step inequalities with variables on one side and with variables on both sides. You got 2 prove it problems. And remember, you can check this when you get done. Pick any number that works, plug it in and make sure that it makes the inequality true. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.